In this video, we are going to learn about prime factorization. So what is a prime number? A prime number is a number that has only two factors. That is 1 and the number itself. You might be wondering, well, what are factors? Factors are numbers we can multiply together to get another number. So let's look at some examples to see if they are prime or not. So we have 5. And if we break apart 5, which I'm not going to explain how that works right now, you see that the factors of 5 are just 1 and itself, 5. So 5 is considered prime. Let's look at 6. If we break apart 6, you can see that it actually has more factors than just 1 in itself. So it is not prime. Let's look at 8. Same thing with 8. If we break apart 8, it has a lot more factors than just 1 in itself. So it is not prime either. Last one, let's look at 9. If we break apart 9, 9 also has more factors than just 1 in itself. So 9 is also not prime. So here, the only example of a prime number would be the 5. So I think it's important for you to have documented or to write down somewhere prime numbers from 2 to 199 because it is going to be helpful as you go through these prime factorizations to actually know when you see a prime number. An important part of the prime factorization process for me is to first identify even and odd numbers. And so to do so, you need to know that even numbers always end with the last digit as either 0, 2, 4, 6, or 8. So let's look at some examples of even numbers. So as you can see in these examples, the last digits all end in, the first one ends in 4, the last digit is 6, and the next number, the last digit is 8, and the next number and the last digit is 0, and that last number 300. And so those are all examples of even numbers. So let's look at odd numbers. Odd numbers always end with the last digit as either 1, 3, 5, 7, or 9. So examples of odd numbers would be listed here. As you can see, their last digits are, the first one is a 5, the second one is a 9, the third one is a 3, and the last one is a 1. So all 4 of these numbers are odd numbers. All right, so let's look at our first example. We're going to find the prime factorization of the given number, which is 18. I've created a chart for you to just kind of go through like the process. So let me just explain the chart quickly here. So the first thing you want to ask yourself when you're working through these prime factorizations is the number even or odd? And so you identify whether it's even or it's odd. If it's even, you're going to divide the number by 2 first. If it's odd, you're going to try to divide it by 3. And then you're going to see, does it work? When you divide these numbers, you don't want to get a decimal or any type of remainder. So if you do get a decimal, then a 3, when you divide by 3, and then that means it didn't work. If you get a whole number, then that means yes, it works. And so you just continue throughout this process as you're going through the prime factorization, and you'll understand that more as we do some examples. And so if it doesn't work, then you want to try the other prime numbers going through the list. So if 3 didn't work, then you want to try 5, then you want to try 7, then 11, and then go so forth. So let's start with 18. So the last digit in 18 is an 8. And so since it's an 8, that means the number is going to be even. So we're going to divide by 2. When we divide by 2, we get 9. So then we want to see, we want to ask ourselves, is 9 a prime number? So looking at that list, you should see that no, 9 is not a prime number. So then we want to go through that same process that we did with 18. We want to do that same process with 9. So is 9 even or is it odd? Well, 9 itself is odd, and so we are going to try to divide by 3. And so when we divide by 3, it actually works. And so 9 is 3 times 3, so that's how we represent it there. And then same process, we want to ask, is 3 prime? It is. And so we're actually done with our prime factorization. And so to write that out, 18 is going to be equal to 2 times 3 times 3. All right, let's look at example 2. We're going to do the same process. Let's find the prime factorization of the given number 35. So when we look at 35, the last digit is a 5. So that means that 35 is actually odd. So we're going to try to divide by 3. And when you do that, you get 35 divided by 3 is going to give you a decimal, and it doesn't work. So then you want to next try to divide by 5. And so when you divide 35 by 5, you get 7. And so 5 is a prime number, and then the 7, we got to ask ourselves, is that prime? Because if it is prime, that means we're done. We're done with the prime factorization. And so 7 is prime, and so we are done with the prime factorization. So 35 is equal to 5 times 7, because those are the primes that make up 35. Okay, let's look at example 3, which is our last example. Let's find the prime factorization of 315. So the first step of the process is to identify the last digit. The last digit is a 5, so that means that it's odd. And so we're going to divide by 3 first and to see if it works. And when you do that, 315 divided by 3 is 105, so it does work. So 3 is our first prime. So then we got to figure out, is 105 prime? So you can look at that chart from earlier, and you should see that 105 is not prime. So then we got to go through that same process to break down 105 that we did with 315. So is 105, is it even or odd? Well, the last digit is a 5 again, so that means that it's odd. So we're going to try to divide 105 by 3. And when we do that, it does work. And we get 35. And so 3 is our second prime. And so then we want to see, is 35 prime? And 35 is not prime. It's not in that chart. And we actually just did it in example 2 as well. And that showed that it wasn't prime. And so 35, we got to go through that same process. 35, the last digit of 35 is a 5. And so that means that it's odd again. And so we want to try to divide by 3, but as we saw earlier, it doesn't work. And so what does work is dividing by 5. And when you do that, you get 7. And 7 is a prime, so we are done. So the prime factorization of 315 is going to be 3 times 3 times 5 times 7. And that's it.